Welcome, everybody. Thank you all for joining us this evening for tonight's first ever Stratford Chapter webinar. Tonight, Jonathan Hartman is going to be discussing, answering the question, is urban air mobility really disruptive? Tonight, I will be your moderator, Alex Mark. I am the Stratford Chapter President. We'll be running these events throughout the fall in place of our traditional dinner talks that we normally would have. So any feedback you have on tonight's event, as I said, this is our first, would be greatly appreciated. If we can make anything go smoother next time, please let us know. Throughout the presentation, we will be doing questions during and after. The way we'll be doing questions tonight is using the question box that you can find in your GoToWebinar control panel. So if you have a question, feel free to type your question in there. And we will work hard to get that to Jonathan to respond, or if you have any sort of IT-related question, again, feel free to put your question in there and I will answer that and take that off John's hands. This event will be recorded, so just please take that into consideration with your questions. And as we go through the questions, I will be sure to repeat them, or John will repeat the question before we answer them. Next month, on September 16th, we will be having Audrey Brady, who is the VP of Commercial Systems and Services at Sikorsky Aircraft, join us. We'll be sending out the flyers shortly for that event. Really excited to have her come talk to the VFS community. Tonight, we have the honor to be sponsored by Dassault Systems. John Dixon, Client Executive, Aerospace and Defense, is here with us tonight. And we can't thank you enough, John, for all your support over the years for the VFS chapter. Let me hand it over to you for a little speech.
Great, thanks, Alex. So I'm John Dixon. I'm the Dassault Systems Client Executive for the RMS division of Lockheed Martin. For those that don't know Dassault Systems, you may know us by our flagship brand CATIA and the CAD software that we produce. We've been partnering with VFS for, I think, 2 years now, Alex, and sponsoring several of these events throughout the year. So we're excited to get to do another one and bring the virtual events back. Dassault has worked with Sikorsky since the early 80s, when Sikorsky adopted early versions of our CATIA software for mechanical design. We've over the years, we've grown that into the product data management area in the early 90s. And I actually believe last week was the 1-year anniversary of Sikorsky going live in production on the latest version of our software, the 3D Experience platform. So since I know everybody's here to hear Jonathan talk and not me, I'll just point you to, there's a banner at the bottom of the invitation flyer that Alex sent out. It's a link to our virtual customer forums that we're conducting. And actually, last month, we had Renee Passman from the ADP organization of Lockheed Martin do a keynote, and her speech is up there, and she covers the way Lockheed Aero is transforming using our software. So I'd encourage everybody to click on that link and go take a look at the videos out there. And I think I'll end it there. Thank you for the opportunity, Alex, and I appreciate being invited.
No, thank you so much, John. We really appreciate all your support. So to get to it, tonight's presenter, Jonathan Hartman of Sikorsky Innovations. So just a little bit here. Jonathan serves as the Disruptive Technologies Lead for Sikorsky Innovations, the organization responsible for maturing next generation products and technology for Sikorsky Aircraft. In this role, Jonathan leads the identification and maturation of game-changing technologies through collaborations with customers and innovation's global network of partners, helping to set the company strategy for the future of rotary wing flight. Since joining Sikorsky in 2009, a short time ago, since I joined the same year, his responsibilities have grown to include a wide range of roles. He's had experience in technical project management, business acquisition, strategic planning, and international partnership development. His current technical portfolio includes maturation of future vertical concepts, next generation energy storage use, and advanced manufacturing technologies and processes, as well as autonomy-enabled product offerings. Jonathan also champions Sikorsky's open innovation initiatives, which highlight the support revolutionary ventures and innovations with aerospace relevant technology. Jonathan previously served as program manager for Project Firefly, an all-electric technology demonstrator helicopter. And Jonathan received his Bachelor's of Science in Mechanical Engineering at Yale University and received his Master's of Business Administration degree from Johns Hopkins Carey Business School. His work has been published and cited in various technical publications. He currently holds 4 published patents in the area of control systems and applications for electronic propulsion. He actively serves on several nonprofit advisory and governing boards, including Yale Science and Engineering Alumni Association and Aero Innovet. So just real quickly before we get to John, I just wanted to repeat, we have some more people joining. If you have any questions, please type them into the question box, and we'll be sure to get those answered throughout the presentation tonight. And with that, John, let me hand it on to you.
Thanks, and really appreciate it. So let me just start my video, and hopefully everybody can see me. Good evening, everyone. Really a pleasure to be here. Thank you to the VFS Stratford Chapter for the introduction and for the invitation to present. I know this is going to be a little bit unconventional tonight. Instead of talking in front of you, I'm talking here in my home office to a camera. So I'll do my best not to laugh at my own jokes and look forward to just your questions and interaction as we go through this. Since this is the first time that we're doing this as a VFS Stratford chapter, I'm going to ask our moderator if there's anything going on with either my video or my voice, whatever. Feel free to interrupt me as we go through. And again, a little non-traditional, please feel free to ask your questions live. I will get them here on this screen. I'll do my best to answer them as they come in. And then certainly if there's any at the end, we can address those as well. So in starting this and being asked to choose kind of a topic, I decided to think about something that is really top of mind for all of us in the aerospace industry today, which is this concept of urban air mobility, right? I think we're all talking about it in some way, shape, or form. We're all engaging, and we're seeing a lot of energy and enthusiasm around this space. And as the Disruptive Technologies Lead, I had to just start with the question, is this new space really disruptive? And what I mean by that, and where we're going to go tonight, is I want to explore the theory of disruptive innovation, but this isn't an academic exercise. The point is to give a little bit of background on what it is, why I think it's important that we are precise in our definition of what is and isn't disruptive. Then I'll posit some things for us to kind of walk through, some examples in the urban air mobility space, and we'll put it to the test. And I'm going to come to some conclusions. Look forward to the audience's reactions to those conclusions and maybe making some of your own. So as we dive in, just first things first. So tonight, I am presenting as Jonathan Hartman. So the views I'm expressing are my own and not necessarily representative of my employer or really any other organization that I'm affiliated with. I am thankful for the opportunity to volunteer and talk to you guys about this, but do want to be just very clear about that up front. So let's address first urban air mobility. And really, what is it? Because urban air mobility means many things to many different people. And I think quite often now we are confusing the vehicles and the mission that those vehicles are executing. So the way I like to think about this is urban air mobility as a mission is a new term for an old mission, which is moving people and goods around cities. However, what is new? What is new is this introduction of electrification of aircraft powertrains. And what that's allowing the industry to do is rethink configurations and aircraft design that was deemed too complex, too costly, or just generally poor performance versus some of the more traditional single main rotor designs, which is why I included the Wheel of Fortune, as we like to call it, for the various configurations that have been looked at over the years with VTOL capability. I know we're all familiar with that. So urban air mobility, and this thought about urban air mobility, is being enabled by electrification. What the companies that I've seen are doing is taking that electrification and actively trading traditional metrics of aircraft performance, payload and range, for things like cost, acoustics, community acceptance. So we're thinking about aircraft that maybe go shorter distances, that carry less people or are less efficient, but can integrate more holistically, possibly, into the urban environment than some more traditional configurations. And then lastly, of course, what they're doing with this trade, and really the mission they're going after, is seeking to provide greater mobility and greater, really rapid mobility versus congested ground, water, rail transportation options, right? The primary value proposition of urban air mobility is being able to get from your origin to your destination much faster than you would be able to through other transportation means. So urban air mobility is a mission. It's a set of vehicles that might meet that mission. And then it's a new way of thinking about how those vehicles integrate with the rest of the transportation infrastructure. So a way to start putting that together, and I just wanted that in the back of everybody's mind as we get going. So now that we have that out of the way, first question to ask is, of course, okay, what is disruption? And really, why is it important? Well, so the rise of really disruptive innovation or disruptive technologies can be attributed to this man on your screen. And I think most of you know him, but if you don't, this is Professor Clayton Christensen, the late professor at the Harvard Business School. His and his research colleagues' seminal work in 1995, I believe, which was Catching the Wave, the Rise of Disruptive Technologies, was the paper that coined the term and also coined the theory behind it. Since then, there's been a number of revisions published to that theory by Professor Christensen, and as well a number of folks who have tried to re-examine the theory in terms of usefulness. Now, one of the reasons I was passionate about bringing this topic to VFS was Professor Christensen passed away earlier this year, but his theory has left such a fundamental mark on how we think about technology innovation that it was worth kind of exploring deeply. Now, one of the things that I have noticed, and I think others have as well, is that unfortunately disruptive innovation or disruptive technologies has become so widely applied that its utility has almost diminished. And what I mean by that is if you look at the number of publications, citations, people using that word, it's been an exponential increase since it was termed in 95. And what's happening now is we are attaching disruptive innovation or the word disruptive to really anything that we want to use and call out as new, exciting, and different. But that's not what disruptive innovation actually means in Christensen's theory. And there's a real business reason to be precise about the use of the word. So to dive into that a little bit, let me show you just how I think about disruption, and it pulls from the Christensen theory. So the theory of disruptive innovation says there's essentially two kinds of innovation. There's sustaining innovation, and then there's true disruptive innovation. I've really broken sustaining innovation down into what I call evolutionary, revolutionary, and breakthrough. So these 4 levels of innovation fundamentally get down to the level of risk to the incumbents in the field. So on the far left side, you have what I would call just evolutionary sustaining innovation, which is improvements on an existing product, the things we do every day in standard course of business. Then there's revolutionary sustaining innovation, which is you're still on the same product, but you have introduced a substantial capability upgrade, something that is vastly different from just a normal trajectory of product improvements. Breakthrough is a new solution that can replace an existing offering or offer an alternative to an incumbent's customers. And then true disruptive innovation is all about offering a new offering to the market that invalidates the current business model. And that's why this is important. Because if you have a sustaining innovation in your business, a business can choose how to react to that innovation as part of its normal course of competitive analysis, right? Sustaining innovations represent varying levels of competitive threats to a company, but you are competing within the same marketplace with the same differentiators. For those rare instances where you have a true disruption, you are essentially resetting the competitive landscape. You are erasing traditional barriers to entry, and you are erasing the traditional leadership positions of incumbents. And as a result, if you are an incumbent in that market, a disruptive event is one that you must respond to if you are to survive that reordering of the marketplace. Now you notice I said must respond, not must respond quickly. Disruption, and we'll get to it in a little bit, doesn't happen overnight. And for various industries and various timelines, that can be a rather elongated process. But what is clear is that when you have a disruptive event, an incumbent must respond. When you have a sustaining innovation event, an incumbent can respond, but can do so within their existing timing. So bringing it back together, the precision of your analysis of a competitive threat directly relates to the timing and the expenditure of company resources to address that threat. And disruption should be reserved only for those very rare instances where you are facing what I would call an existential event to either your technological or business model positioning. So we care about the precision of the term because it leads to business decisions. Now the question we have to ask ourselves is, what is disruption? And what is disruptive innovation, and can you put a model around it? So let's set a quick foundation, and let's at the same time debunk a few myths around disruption, because this will help us all get to the same understanding of the theory. So for me, just saying something is disruptive is not sufficient, because a disruption happens because of something, and it also happens to someone. So when you're thinking about disruption, it's the object, the solution, the product, and then the target of that disruption. And we'll see why that becomes pretty important as we think through urban air mobility. The second thing, disruptive doesn't necessarily mean a large market opportunity, and not disruptive doesn't necessarily mean a small market opportunity. There are plenty of market opportunities and products out there that have a tremendous market potential that do not fundamentally reset one industry over another. Conversely, you can disrupt an industry and make very little money doing it. So just being disruptive is not sufficient to have a business model. And just because something isn't disruptive doesn't mean that there isn't going to be a massive opportunity for companies out there that want to take advantage of it. Another piece about disruptive is being disruptive doesn't mean you're necessarily a successful company. I think there are folks out there who say any company that's been successful, any company that's a unicorn startup or something like that must have been disruptive. Not necessarily true. And if you look at them, if you limit your subset to just companies that were successful, you will miss some insights about disruptive innovation. And just as 95+% of all products fail, there are many disruptive products that have also failed to gain market traction. Disruptive is not just about technology. And as a matter of fact, technology sometimes has been in place for a significant period of time before a disruption occurs. We can think about something like Apple and the iPod, right? It's a classic that gets brought up with Apple disrupting Sony and the Walkman and really music business. But when you dig into that a little bit, MP3s and digital music were already an established technology when Apple came along. What Apple did was actually match the technology with a business model, which was iTunes. And in reality, it's the business model that technologies enable that are often the source of the disruption more than the technology themselves. So you have to pair what the engineering side of the equation does with what it means from a business perspective. And Christensen was quick to point out that most disruptive companies actually focus on a business model first and perfect that business model and then accelerate that business model, which turns into disruption for incumbents. The last one for you is disruption is not a one-time event. It's not something you wake up to one day and say, I've been disrupted. You will get there, but disruption is a process. And the ability or inability or actions or inactions that players take during that process will determine the level of disruption. We can think of examples of disruption that have taken tens to dozens of years to complete. One could say even some of the retail models that we're seeing now that were started 30 and 40 years ago still haven't fully disrupted their incumbents. So this can be a long process. It can be a short process. The key is that the disruptors move faster than their incumbents' response. So disruptive innovation, according to Christensen, is based on a basic premise that says that there is a market where incumbents are improving their technologies along a fairly sustained path. And that if you look at segmenting the market between what would be, in this case, most demanding to least demanding, you could say that's based on price, you could say that's based on performance, that incumbents are improving their products to meet the higher end of that marketplace. And they are leaving a bunch of folks in the marketplace that would be willing to use the product or willing to use something like the product if there was a quote unquote more affordable option. And what disruptors do is start at that lower end of the market and quickly, and again, quickly in the context of their incumbents, move up that performance, quality, cost ladder to the core customers that the incumbents are then serving. And by the time the disruptors get there, the incumbents are unable to respond. And thus you have a reordering of the marketplace. Now, what's important here to note is that the original theory of disruption, which started in 95, was really based on the theory of price. That if you could start at the lower cost end of the market and move up, that was disruptive. What we've seen over time is actually examples where folks have come in at the top end of the market and moved down in affordability and have still been disruptive. And what that's about is about establishing a new market. So you're establishing consumers not by those that the incumbents have left behind from where they were, but consumers who would have otherwise never used the product that are now using the product. So again, a little theoretical, let me give you kind of two case studies we can walk through. The first, streaming entertainment. Now, I don't know how many on the attendees here remember Be Kind Rewind in the Blockbuster days, but I do. If we think back to the original start of streaming entertainment, and one of the founders obviously being Netflix, started as what would be seen as a inferior quality offering to something like Blockbuster. Blockbuster was a physical store that you could walk into at any time and rent a top movie that had just come out of the box office. Netflix started with the DVD mailing, and again, if you were, I'm dating myself a little, but the selecting the DVDs off of your AOL dial-up connection, and then letting those come to your house over 2 or 3 days, watching them, returning them, and getting more, was something you had to be thinking ahead about, right? I remember my family had the 3 DVD or DVD plan, such that you could watch one a day, and by the time you were done with your last one, the new ones were showing up. And that was something that was, a way for Netflix to set, as I was talking about earlier, their business model, which was about titles that maybe weren't right out of the movie theater, but they were offering a much more massive selection. And by centralizing the location of those assets, could offer them to anyone. And then we got to the kind of the red box side of things, where you had physical locations with a lower selection but were cheaper, right? Videotape at Blockbuster or DVD at Blockbuster was much more expensive than Redbox started out. And so you watch these competitors and disruptors, I would call them, move up market very quickly as streaming entertainment became, and broadband connections enabled that streaming entertainment. And what we ended up seeing was the end of traditional big box video rental stores, right? I just saw an advertisement that said that one of the last Blockbusters is being offered as a Airbnb for the night, so you can enjoy a bit of nostalgia there. We all have to remember that Blockbuster was a massive company at one time that has been replaced because their fundamental business model of distributed stores that had to stock physical assets was replaced by a company that took advantage of that technology, which was the digital technology. So that's a classic example. One that runs counter to the theory, and I think caused Christensen and his colleagues to step back and say, what is this new market disruption and how do we deal with it, was ride sharing services, right? Let's think about that. Again, digital technology enabling much more convenience in accessing a ride, cashless payment for that ride, and better tracking of where that ride was or availability of those rides, versus a traditional taxi medallion market, highly regulated, heavy asset ownership and unable to move out of the box that they were in. But Uber didn't start, and all of the other sharing services did not start at the low end of the market, at the most affordable end of the market. As a matter of fact, they started as a town car service, as a limousine replacement service, the highest end of the marketplace, the highest cost. But what they were able to do was utilize that smaller pool of consumers to perfect a business model so that when they came down in price into the mass market and were competing with taxis, they were able to offer a refined business model that the taxi market couldn't meet. And as a result, we've seen medallion prices plummet, lots of uncertainty in that marketplace. And yes, you can contend that the way in which some of those ride-sharing services do that, which is divesting themselves of assets to become an asset-light business, they don't own the cars, is an interesting way to execute that model. But it's certainly a model that is bringing new customers in, that is keeping new customers there, and is causing pain in the traditional incumbents in that space. So, with those kind of couple examples of innovation and the theory of innovation, I like to move it to a set of executable questions that I ask myself as we evaluate technologies, right? Because looking at a graph like this is fantastic in an MBA class, but trying to make these actionable take a little bit more refinement. So the way I interpret the theory of disruptive innovation and what I use is 4 questions that I ask myself and 4 questions that I try and ensure I'm answering appropriately and revisit often, because something that's disruptive today might not be tomorrow and vice versa. So the first one may seem a little strange. Are the offerings being hired for the same job, right? And we're going to get to what that means and what a job is and why that's important. It's a tenet that's not normally associated directly with disruptive innovation, but an important one. The second question, does the offering create either a low-end foothold or a new market foothold? This is, very central to the theme we were just talking about. Does that offering, does that solution start in a place that incumbents are not? And because they start there, are we and our peers, so the market that I am looking at, likely to ignore them for some time? Because disruption really occurs in its truest form when small, less resourced companies displace larger, better resourced, longer time in market companies. And so the ability to do that requires a little bit of time where the incumbents aren't looking at you. And I see a great question here. Are we getting to urban air mobility at any point? Yes, we are. So we're setting a foundation here. I promise you the next slide, we turn this right over to urban air mobility. And then the last question to ask is, if successful, would we and our peers find it difficult to respond? If a disruptor caught up to our core market and our core customers, would we, I think Christensen used the term, flounder about before ultimately being disrupted? So those are the 4 questions you have to ask yourself. So we're going to ask ourselves those 4 questions in the context of 2 proofs, which is why I said we're getting to urban air mobility. So the first proof we're going to ask is urban air mobility solutions, those aircraft that are targeting the urban air mobility mission, are they or are they not disruptive to current participants in the rotorcraft market, people that make helicopters? And then I wanted to take it a step further, because urban air mobility is tied to that electrification question. So is the fundamental technology behind the solutions, that is electric propulsion, is that or is that not disruptive to the rotorcraft market? So let's dive into both of those in the context of the 4 questions. So first, being hired for the same job. And what does that mean? Again, slight anecdote. I'll take 2 minutes, I promise. And you're going to ask yourself, why is a presentation on urban air mobility involve desserts, possibly breakfast food, and video games? So this was a story that really stuck with me in my MBA time, and this was from Christensen. It's called milkshake marketing. So he and his colleagues were hired by a fast food chain, and they were hired in order to increase the sales of milkshakes. And so this fast food company had done a traditional marketing plan where they had segmented the market by age groups and demographics and all sorts of things. And they had gone out to those age groups and demographics and they had asked them questions. What could we do better with our milkshakes? And the respondents answered the best they could. The restaurant food chain made some changes and milkshake sales didn't improve. So one of Christensen's colleagues actually sat in one of these food chain restaurants for a day. And what they noticed was fascinating, which was they were selling a lot of milkshakes in the morning, right around rush hour. And when they started asking drivers, why are you buying a milkshake at 6:30 in the morning? A set of answers came up, which is that they had a boring commute. They wanted something to entertain them. They knew that at any one time they would have between 0 and 1 hand available. And they knew that they were going to get hungry by 10 in the morning because they were leaving early for work. But they wanted to be hungry in time for lunch. So for them, the milkshake was filling a job, which was entertainment and nutrition. So the Christensen team said you should thicken the milkshakes to make it take more time to drink them. And you should add fruit combinations and things like that to make them more appealing to a breakfast crowd. They suggested that, milkshake sales went up. But then that same colleague also noticed that the people who were buying milkshakes in the afternoon were mainly parents with children. And the point of the milkshake was to entertain the children during a drive. And so there, thicker milkshakes actually made children more frustrated and would cause them to be upset and void the reality of that job that they needed to fill, which was entertainment. So in that case, the milkshake was filling the job of a Game Boy, a video screen, or some other form of entertainment. So the Christensen team said, hey, in the afternoon, make the milkshakes a little thinner, make them easier for the kids to drink. Milkshake sales went up. What's the point of this story? It's not about to make you hungry or make you go out and get a milkshake, but it's about figuring out what the right job the product is being hired for. And is the product being hired for the same job as the product you're building? Think about it this way. Automakers started introducing Wi-Fi into cars, right? Great opportunity, great thing for them. But they targeted pickup trucks and utility vehicles at the beginning. And that was because for many people, their truck is their home office and their office on the road. So in that case, the vehicle is being hired to do a job which is replace a brick and mortar office. So just because you have a product that looks like another product doesn't necessarily mean it's being hired for the same job, and vice versa. So from that end, let's put that in the context of our 2 proofs, urban air mobility and electric propulsion. So what are we actually hiring urban air mobility solutions to do for us? Well, at their most basic level, it's about moving people and goods from one destination to another. And if you stop there and you say, okay, helicopters and rotorcraft move people and goods from one destination to another, urban air mobility solutions do the same. they're being hired for the same job. But let's dig a little deeper. So you could say to move people and goods from one destination to another, and those terminal points require VTOL, because that first statement could apply to cars, trucks, trains, boats, take your pick. But as soon as you need to take off and land vertically or fairly vertically, now we're down to kind of rotorcraft and urban air mobility solutions. But if you, again, dive deeper and say, well, really, if what you want to hire something to move thousands of pounds of stuff, hundreds of miles, now you're starting, as we talked earlier, to get outside the realm of what urban air mobility products are doing today. And you could say, well, Jonathan, you know, that's a quality issue or a performance issue. They're starting at the lower end of the market and moving up. But to me, the biggest difference is that you're moving these goods from far destinations that are far apart, but require sustained vertical takeoff and landing capabilities at some point during the mission for it to be successful. We've heard a lot of folks in urban air mobility say that in order to make the design space close, they need to reduce their hover times. And hover is not really a requirement of the urban air mobility mission. And so when you do that, you are asking the urban air mobility product to do a different job than really a helicopter is designed for, which is efficient hovering. Sorry about that. So to me, you end up with a mismatch in the jobs you're being hired for. Electric propulsion is a bit of a different story. So when you think about electric propulsion in vehicle design, what are you hiring it to do? Well, you're hiring it to transmit power between a generation or a storage device to a consumption device. Yeah, that makes sense. Today we use drive shafts and transmissions. Tomorrow we could use electrical cables. So take that a step further, and excuse me 1 second, I'm going to take a drink of water. And you could say, okay, well, next level down is it's transmitting significant amounts of power between large sources and sinks, still holds. And then finally, transmitting large amounts of power between sources and sinks in a high vibratory environment, right? We all know helicopters and rotorcraft and VTOL and vibration are a fact of aerospace. So in that case, I think the job actually holds, because what electric propulsion is doing, or electrified propulsion is doing, is the same job as what we ask our traditional powertrains to do today. So that's the job question. Now, the second question becomes, are urban air mobility solutions and electric propulsion solutions starting in places that the current market has overlooked? And this one to me is fairly straightforward and I think intuitive to all of us, right? From an urban air mobility standpoint, they are absolutely addressing customers that either can't afford, want to fly in helicopters today and can't, or more likely, have never considered aerial mobility as a solution, right? And use ground mobility today, whether that's for parcel delivery or people movement. This is a graph here just as a kind of factual point for the number of people that are passengers in US bound and trafficked airports. And you can see the total is about 1 billion people. Some industry experts say 1 in 5 people have flown commercially to date. That means 80% of the world has never actually stepped foot in an airplane. You can imagine that while I don't have the data, that the people who have stepped in a rotorcraft are much less. And while I would be a big fan personally of having a Sikorsky S-76D land on my street and pick me up every morning and the 8 or 9 minute flight to the main plant from my house, I know that that's not something for me that's affordable today. And so urban air mobility and the push for these vehicles to address a much lower price point is certainly a low-hanging fruit. And just real quick, before I move on, we did get a question here on the job of electric propulsion, which is, would the job of electric propulsion also include for a sustained period, i.e. current battery technology is only limited to around 30 minutes of flight, but fuel-powered rotorcraft typically have around 2 hours of flight or more? That's a great question, and actually a great lead-in to the next chart, which is exactly to your point. It's less about the same job for that one. I do believe that urban air mobility solutions and really electric propulsion are starting at a low end from a performance standpoint. This is a representative graph. I wouldn't have anybody here get too excited about any particular point or curve on this. But all that is to say is that as far as battery technology has advanced, the axis of both the X and Y that get us to the dot where JP8 fuel density is way up and to the right. So to me, both electric propulsion and the vehicles they produce in urban air mobility are starting at the lower end of the performance market, and they are taking new customers as well with them. So let's get to the third question, or the third disruptive innovation question to ask, which is, are the market incumbents ignoring them? From a urban air mobility perspective, I would say definitely not. And from an electric propulsion perspective, I would say definitely not. So I had to put this up here. Alex, you mentioned, that 2009 was only a little while ago. The far left picture is me in 2010. I know I look a little different now, but that was our Firefly program where we were starting to think about the impacts of electric propulsion on our products. And so the large aerospace OEMs have been thinking about the implications of electric propulsion and the urban air mobility missions for a while now. This is not something we are ignoring. This is not something that we are saying isn't going to happen. How we do that and the process by which we continue to invest in that is certainly open for discussion. But I would say from a standpoint of, are we not seeing the trend? I think we're certainly seeing the trend. Now, the last question is, okay, even if you see the trend, if a disruptor comes into your core market, how difficult would it be for rotorcraft OEMs to respond? And there's two things we have to think about here. The first really is urban air mobility solutions and the business models they enable, right? So I've taken just a very top level kind of breakdown of the rotorcraft OEM to end user value chain, right? That goes all the way on the left from the supply chain. Those suppliers provide parts to a vehicle OEM that makes a vehicle. That vehicle OEM interacts with the certification agency and can also interact with financing agencies to enable the purchase of their aircraft. Those OEMs then provide the aircraft to operators or individuals, customers. Those operators also can interact with financing. They interact with insurance, and they also then operate the vehicles, which means they have to interact with the infrastructure providers, right, where you're taking off and landing from. And then at the end of the day, you have the end users, the people who actually fly in the aircraft. And in many cases, if you're taking a flight by yourself and trying to find an operator, you can interact with many of them in order to find a flight. You can also interact with the infrastructure providers directly. It's a very, it can be a very complicated, multifaceted interaction. So what are the new business models that urban air mobility is thinking about? And how do those relate to our current incumbents in the rotorcraft market and our ability to respond to those? I personally have seen two new takes on business models. The first is what I'm going to call demand aggregators. And There's a few that come to mind, top of mind more than others, but this is the demand side of the equation that are using digital tools to correlate and bring together those end users, act as in some cases, as a pseudo operator of the vehicle, and in some cases provide the infrastructure and the financing for those vehicles themselves. So think vertiports that are owned by that company and
Okay, I apologize, everyone. Looks like having a little communication issue, John. I think we're back almost.
air
Okay,
mobility.
here oh, there we go. Gotcha.
Oh, did I dropped out there for a minute?
Yeah, we just got you back.
Okay.
Appreciate it.
And hopefully my screen's still up.
Yep, looks good. Sorry, keep going. You're good.
No. Thank you for letting me know. So let me just go back. So not to be terribly repetitive, but what I was saying was, as a demand aggregator, I don't see that as being something that traditional rotorcraft OEMs would have a problem with from a disruption standpoint. I think we would adapt to that and adapt to a new customer base. The other one is as some of the new urban air mobility OEMs are actually talking about both making the vehicles as well as owning the vehicles and operating the vehicles. This is a major change from a traditional model, right? As rotorcraft OEMs, we sell those products to customers. We are not a customer in and of ourselves. This one could be a little more difficult for us to respond to. Larger companies, obviously, there's a few questions around how you would become a more asset-heavy business, right? Because that's what we're talking about here is one company not only having to own all of the raw materials all the way through vehicle production, but then own the vehicles for their entire lifetimes and own operating arms that operate those vehicles. But by the same token, historically speaking, companies that have disrupted incumbents have done so by moving out of asset ownership, becoming more agile, more nimble, more cost effective. So going the other way, I'm not sure that I've seen a successful or what I would think would be a successful version of that model yet. But I could be wrong. And if somebody does figure out how to do that, could be something that causes us to take a moment on. So that's urban air mobility. As far as electric propulsion is concerned, I do see there being a lag in an ability to respond if an incumbent has not yet started down that process. And why is that? And I think we all here have an idea on that. But it's because of the learning curve, right? So if we think about integrating new technologies and integrating something as fundamental as a new propulsion system, you have to think about, your core capabilities. You have to think about your processes and methods. You have to think about standards and certifications and partnerships and collaborations and supply chain and the third and fourth order effects that come along with that. So I do think that there could be, if incumbents were not on a journey to understand the technology or did not continue on that journey to gain learnings at the same time as others, a potential thing there. So that's the question. Now, I got another great question on my previous slide, which is people that own assets. And somebody pointed out, they said, well, Jonathan, you know, Sikorsky does have a company called Associated Aircraft Group that does operate aircraft in the New York City area. Would you consider that a form of this model? And it's a great point. And I would say, I do consider that a form of that urban air mobility OEM model that we were just talking about. But I would say it's not a predominant model for us. You know, the model I'm talking about is where 100% of the assets you produce then become owned by you. So I think if you have experience in asset ownership, like a company like Sikorsky does, it might be more straightforward to respond than a company that has no experience doing that. But I think if a company became successful selling 100% of its products to itself and operating that, that is certainly a change from what we have today. So putting this all together, and we're getting to the end here, and really appreciate everybody's questions as we go through here. What has all this meant? So we've walked through the process. I've introduced disruptive technologies and disruptive innovation, at least what it means to me a little bit. We've gone through examples of what that is. But at the end of the day, in order to be considered disruptive, right, that very small percentage of things that actually is, you really need to get a check mark in all 4 categories. Now, when we do the math at the end of the day, what I'm seeing is that urban air mobility solutions, in terms of the existing rotorcraft OEM marketplace, are not disruptive. Urban air mobility solutions are not being hired for the same job. They do start at a different place in the market. OEMs are not unaware of them, and I don't think it would be difficult for incumbents to respond or impossible for them to respond without significant angst. So that's why I gave it a gray check mark. Think of the grays as kind of half check marks. So it checks some of the boxes, but not all of the boxes. And again, I'll step back and say, that doesn't mean that I don't think that urban air mobility is an exciting space with lots of opportunity that's going to generate new participants in the VTOL marketplace. What I do think is that if you are an existing manufacturer of rotorcraft, depending on your size of product that you make, you will continue to be producing those rotorcraft as once urban air mobility is up and running at full scale. Now, if you're a producer of smaller aircraft, where those urban air mobility solutions are a direct competitor, even though they aren't disruptive, it still represents a competitive threat to take seriously. Now, on the other side, I do think that electric propulsion will be one that we continue to watch, and I don't think that's a surprise to anyone here. Propulsion technologies have always driven aerospace. And while we as incumbents are aware of that and are actively investing in it, depending on the trajectory that we move forward with as an industry, I could see the opportunity go one way or the other. That is, I could see it become disruptive, or I could see it be successfully defended. And I think that is a trajectory that's going to take time to evolve. I don't think it's going to happen overnight. And I think it's one that we will all be continuing to evaluate as we move forward. So, kind of the full conclusion here is that I think there are exciting times ahead for the VTOL industry. I think there's a lot of new markets and missions to go after, but I do think in terms of where the current marketplace sits, we will continue to see both a rotorcraft market as well as an urban air mobility market going forward. So that's my last slide. I am happy to take more questions in either the chat box, or I don't know if we're going to unmute people as we go forward, but I'm happy to have just kind of an open discussion on some of the points or conclusions I've made. And thank you everybody again for listening in.
Thank you so much, Jonathan, for presenting today. So anybody, if you have questions, feel free to drop them into the chat menu. If you'd like to do a verbal question, we got a couple coming in here. We can try and raise your hand and we'll try and get to you.
So I've got a first question here, which is, electric propulsion may facilitate entirely new forms of VTOL using distributed propulsors, and my thoughts on that. So first of all, appreciate the question, and I completely agree that electric propulsion can enable us to look at not only configurations that we looked at before and were either too complex or too costly with traditional propulsion, but also enable a design space that really hasn't been considered before. I think that your requirements that you are designing to for the urban air mobility marketplace and the solutions that those will take, independent of configuration, still are not disruptive to the rotorcraft OEM spaces that exist today. Do I think that that could lead to learning and new products that could challenge performance and might be disruptive? Yes, but again, that's more a cautionary tale for the future than a reality of the present. And then now a great other question here, which is, who are the main competitors for developing electric helicopters? And I think, VFS has done a great job tracking those folks and everybody who has a concept through prototype that are taking advantage of electric propulsion. So I'd invite everybody to go take a look at that. I also just saw, I think there was a recent press article that took that data and started thinking about how forward or how advanced some companies are versus others. I will say, I think we've seen some significant capital raises and some prototype developments out of companies like Joby Aviation, out of Lilium, eHang, Volocopter, but I would say that those are a subset, and I shouldn't also leave out Wing, but those are a subset of what is a much larger trade space. And I see a question here, and I'm not sure I'm fully understanding it, so would love a clarification. Does Sikorsky reconsider her distance from the consumer eVTOL market? I think that's directed as, is Sikorsky considering its position within the eVTOL market? And what I would say is, Sikorsky has always been involved in the VTOL market since its inception. We are certainly continuing to be involved in the space, and we're talking a lot about some of those fundamental obstacles that need to be addressed, from safety and reliability on the vehicle part to its integration with infrastructure. So I'd say stay tuned there. And then there's a kind of a companion question that says, do you think that companies have the right electric propulsion for urban air mobility? That's a great question. I think the solution for your propulsion system depends dramatically on your configuration and the mission you are going for. So I think time will tell a bit with that. And I think, quite frankly, we are still very early in that process. So data is being gathered. But I think, as with all new technologies, we will find and optimize the ways we use them as we go forward and learn more. And then another question coming in, what are your thoughts about the piloting of these vehicles and the potential for autonomy? So not really a topic here for the discussion of whether it's disruptive or not, but certainly I do think that the ability to reduce crew workload can improve safety And especially in the highly dynamic environments that these vehicles will be operating in, I see a lot of benefit to assisting technologies. Now, in terms of the question of, do I think that we will get to a point where we can have autonomous aircraft carrying passengers in large volumes around densely populated urban areas? I think there, as with anything else, it's gonna be a stepwise process that's gonna be data driven. And another question, and a good one, comments on an approach using M&A. So for those on the chat, it's the thought of utilizing mergers, acquisitions of smaller companies as either a strategy to get into the urban air mobility market or as a defense against disruptors. And it's a timely question, and one I didn't bring up when we were talking about business models, and why I have a feeling that incumbent OEMs would be able to respond timely to differentiating urban air mobility vehicles. And what I mean by that is, I think that a defense that incumbents can use is acquisition of potential future competitors. And we certainly in aerospace, because of our development timeline, have additional time to see such threats coming and see them coming ahead of when they might be disruptive to our core markets. So I do think that there is opportunity for some of these potential disruptors to exit to incumbents before they actually become disruptors. Another great question, is there a disruptive business model that you do not think is getting attention, or a business model that is being overhyped? Great question. I think so I would say I am still skeptical of business models that require the heavy asset ownership and moving into a integrated structure where you are both manufacturer and operator of vehicles. We've seen models like that happen before. We've also seen them broken apart as monopolies. But I think that's going to be a very tough path forward. So I haven't seen that yet. In terms of one that I don't think is getting enough attention, don't know that I've seen one that I don't think is getting enough attention. But the other problem with business models is they are kept relatively close hold by those companies. So tomorrow I might answer that question differently. Another question. In your opinion, roughly saying, how much capital will eVTOL manufacturers will need for certification and setup of production systems? Great question. I don't have an exact number for you. I will say that I've seen estimates that range anywhere from $100 million to north of $1 billion. I think with such a broad range, you're somewhere in there, but I think you're towards the middle to higher end of that spectrum than you are to the lower end. So would you say, would 2 to 3 kilowatt hour per kilogram at the pack level under at $100 per kilowatt hour capacity give you a significant opportunity? Good question. I'd say, again, each of those are opportunities that are discussed kind of on the aircraft to aircraft level and really mission to mission level. So I don't know that I'd be able to comment exactly right now that says, hey, it's one way or the other. But I appreciate the question. Let's see here. Another great question, do you think that instead of urban air mobility, the disruption will happen on the rural landscape? And this is a great question as we all think about it. Do the short distance flights actually have to be in congested areas in order for them to take hold? Or would infrastructure limited areas like rural areas also serve as a great ground for that market. So I think if such areas, or where such areas exist, certainly there will be less obstacles to introducing them than introducing them in a city. But I think, you know, the key to think about here is, what is that value proposition, right? Congested ground transportation and faster travel times is a very clear value proposition. For rural landscapes that might have more open transportation systems, that's a bit of a different question. And then a great question from somebody here. Even if an urban air mobility business doesn't pan out, don't you believe that these electric propulsion technologies can prove useful to incumbents and products and missions? And I think, you know, there is certainly an argument to be made that electric propulsion represents a new wave of propulsion technologies that will eventually get to the point that they impact all vertical takeoff and landing vehicles. So yes, I do think that the fundamental enabling technology to this UAM mission, which is electric propulsion, is one that incumbents need to watch closely. Okay. Alex, I think I got all of them. If there's any others, please feel free to send more. I think we got, what, a couple more minutes here, maybe for one or two more?
Yeah, one or two more. Sounds good. We got one that just came in here. Send it your way. Yeah, we are, Mark. Go ahead.
And I guess while we're waiting for Mark, there's another question that came in that said, what do you think about connected and integration between UAM and the smart cities? So I personally believe that the ability to connect a new form of mobility with existing infrastructure is very important. And I think it's an area that still needs to be thought about more. You know, we as an aviation industry have often asked for special treatment when it comes to our ability to integrate and embed with infrastructure. And I think in order for such time savings to be useful, we're going to need to think about a new level of integration with fixed infrastructure as well as other forms of transportation. And then another great question, which says, if you were to separate propulsion into motor systems and batteries, would your check marks and conclusions change? I don't think the check marks and conclusions would change if you changed, and I'm going to interpret the question here, fully electric propulsion to more electric or other systems. I still think that you're being hired for the same job. I still think performance is starting at the lower end of the marketplace. I think incumbents are aware, though, and investing. And I'm still have a question mark as to the ability to respond, which is in part due to the acceleration, you know, how quickly those technologies accelerate.
Hi. Would 2 to 3 kilowatt hours per kilogram at pack level make Craig a big enough opening for you if that was in your hands in 2 to 3 years in commercial mass quantities?
Yeah, so great question. I'd say, you know, 2 to 3 kilowatts per kilogram represents in my estimation, probably a 10x improvement over what, you know, current state-of-the-art battery technology looks like. So it's certainly something I'd be interested in learning more about. And then just, you know, again, kind of a final point here, and again, a great question just in terms of urban air mobility and Sikorsky, right? I would say from Sikorsky's standpoint, we continue to participate strongly in this emerging marketplace. We think there are technologies that we are developing and have developed, such as our matrix autonomy system, that have applicability, and look forward to continue to see how the opportunities develop. So, Alex, did you see any others coming in?
We just had one come in. Do you have time for one more?
I have time. We can certainly do that. So that'll be,
Okay.
we'll end on this one. Okay. As for operations, many players are interested in urban air mobility, which includes Part 135, airlines, others. Who do I think will become the main operators and have advantage for the operation of urban air mobility? I hate to end a last question without an answer, but I'm going to put it this way. To me, who operates the vehicle is less critical than the business model that they bring to the operation of those vehicles. So I think it's all about the first or second or maybe third operators that figure out how to optimize their systems and their business models for what that new technology provides. So I think with that, Alex, I really appreciate again the time and the introduction. Hopefully the video came across clearly. Sorry all for the one little spoof there in my audio. But hopefully you enjoyed the conversation, and I am happy to continue it with any of our attendees.
Jonathan, thank you so much. I couldn't thank you enough for being our guinea pig here for our first webinar for the Stratford chapter. You know, it couldn't be a webinar without a little technical problem. So definitely appreciate that. It's kind of like christening a ship. Thank you all for joining tonight, and hope to have you all join September 16th for Audrey Brady's presentation. Appreciate it. Everyone have a great night.
Thank you all.
Get home safe, huh? Yeah.